Lesson 4.4, Parallel and Perpendicular Lines. Our essential question is, how does this slope help you determine whether lines are parallel, perpendicular, or neither? Our two new vocab words, we have parallel lines and perpendicular lines. Parallel lines are lines that have the same slope. So here's a drawing with an example of some parallel lines. Perpendicular slopes, perpendicular lines form 90-degree angles. And what we are going to be working with are the slopes of these lines. So parallel slopes stay the same, perpendicular slopes flip and change. When lines are parallel, they have the exact same slope. They are at the exact same steepness, they're slanted the same amount, so their slopes are exactly the same when they're parallel. When they're perpendicular though, they're forming 90-degree angles, which means that one of the slopes is the opposite reciprocal of the other one. So when we say perpendicular slopes flip and change, we're saying if one slope was 2/3, the other one would be -3/2. So flip meaning reciprocal and change meaning the opposite sign, So parallel slopes are exactly the same, perpendicular slopes flip and change. Anything else? Anything else out there? They're not parallel or perpendicular. I mean, there's certainly a lot of different kinds of lines. They don't have to be parallel or perpendicular. Okay, so our first example says, determine whether the lines are parallel, perpendicular, or neither. So, I am going to move my graph up because these equations are both written in slope-intercept form, so we can graph them right away. We've got our slope and our y-intercept. So my first line that I'm graphing in red starts at the y-intercept 1, and the slope is -3, so if I put a 1 under it, my rise, I'm going to go down 3, run over 1, down 3, over 1. And then I can draw my line. So there's my first one. My second one, the slope is 1/3, and the y-intercept is -2. So I can start at -2 on the y-axis, and rise over run for this one is 1/3, so up 1 over 3, up 1 over 3, and then I can draw my line. So these lines look like they're perpendicular. They look like they're forming a 90-degree angle to me. If I look at their slopes, -3 and +1/3, or -3 over 1 and +1 over 3, they are opposite reciprocals. The slope did flip and change. It did flip and change. So they are perpendicular. My next example, the first equation is not written in slope-intercept form. It's written in standard form, so I do have a couple of options. I could graph the equation from standard form using the intercepts, or I could rewrite it into slope-intercept form. That's the method that I'm going to choose. So I'm going to move it over a little bit. I need to get the y by itself for slope-intercept form. So back in chapter 2, we worked on kind of like the married couple idea, like this 4y, we want to leave them together for now. 4y plus 3x, I would need to subtract 3x on both sides to get the y by itself. So now I've got 4y equals, in this order, I'm going to write my -3x first, then my +12. Because slope-intercept is y equals mx plus b, not y equals b plus mx. So I need the x after the equal sign. Second step, divide to get rid of the 4, and I divide everything by 4. So y equals negative 3/4 x plus 3. So I'm going to start at 3 on my graph, that's my intercept, and I'm going to go down 3 over 4, down 3 over 4 to graph my first line. There it is. My second line, I'm going to graph in blue, has a slope of 2 and a y-intercept of negative 1. So I start out at negative 1. My slope is 2, or 2 over 1. So rise 2, run 1. Rise 2, run 1. And there's my line. Now, these lines, they could look like they're perpendicular. They look pretty good, they intersect. But if you look at the slopes in particular, you'll see that one of them is negative 3/4 and the other one is 2 over 1. They are not opposite reciprocals. They did not flip and change. If one of my slopes is negative 3/4, the other one would have to be positive 4/3. So positive 4/3 is not the same as 2 over 1. So these are not perpendicular. They're also not parallel because parallel slopes stay the same. So these have to be neither. If you just graphed them, you may have selected that they were perpendicular and then you would have the wrong answer. So make sure that you are actually comparing their slopes. So comparing these two slopes to each other, they did not flip and change. They changed sign, but they did not flip. They're not reciprocals of each other. Okay, the next one. My first equation, I'm going to have to subtract 4x on both sides. So 6y equals negative 4x plus 18. And then divide everything by the 6. So y equals, my slope reduces to negative 2/3, and then my intercept reduces to 3. So start out at 3 on the y-axis, down 2 over 3. And here's my first line. My second one, there's only one thing I need to do on this one. I just need to divide everything by 3 to get the y all by itself. So this line has a slope, negative 2/3, and the intercept reduces to 2. So I start out at 2, down 2 over 3, down 2 over 3. So you can probably already tell that these lines are parallel. Their slopes, parallel slopes, stay the same. These slopes are exactly the same. So these lines are parallel. Now, color-coded, we have some systems over here, 5 of them to be exact. Parallel slopes stay the same, so this one has to be parallel. And so does this, because their slopes stayed the same. Perpendicular slopes, they have to flip and change. So these slopes flipped, but they did not change signs because they're both positives. So it's neither. This next one, though, one of the slopes is negative 4, or negative 4 over 1. The other one is positive 1/4. So they did flip and change. And the last one is neither, because they did change signs, but they didn't flip. One of these would have had to have been a 1/2, either positive or negative. So we've got one parallel set. Nope, 2 parallel sets, 1 perpendicular and 2 that are neither. Okay, you should be able to write your summary now. And here are your homework problems.